diode. Okay, and this last one is variation in IC naught. So how I'm going to tackle for variation in IC naught? IC naught is the collector leakage current. So see here, I'm going to have an voltage divider bias. So I'm going to have an voltage divider bias R1, R2, but instead of R2, I'm going to have D. I'm going to have a diode. I'm going to have RC and I'm going to ground my emitter. So this is a simple circuit which will help in making your collector current constant when IC naught is going to vary. So see here, this shows a transistor amplifier. I'm going to connect a diode D across the base emitter junction for compensation in the collector saturation current D. Okay, I'm going to connect this D across the base emitter junction. And same assumption, diode and transistor are made of same material. Okay, but what only one thing, the diode is reverse biased. You see here, negative of diode is connected to positive of battery, and the positive of diode is connected to ground. So which means that the diode is reverse biased. So allowing the reverse saturation current will flow in the opposite way. Normally the current will flow this way when it is forward biased, but since the diode is reverse biased, the reverse saturation current will flow in the opposite direction. So I naught will flow in this way. It will be flowing towards ground. Okay, diode is of the same material as that of transistor, and it is always reverse biased. So a reverse saturation current I naught will flow through the diode to from base to the ground. So this is the direction of flow of I naught from base towards the ground. So if you apply Kirchhoff's current law at this point, one current is coming, two currents are outgoing. So what should be the KCL equation at this node base? Sum of incoming currents equal to sum of outgoing currents, right? So can anybody say the KCL equation at this base of this transistor? Yes, please say the equation for KCL at the base of the transistor. What is the current coming in? What is the current coming in? What is the current which is coming in?
I
I. What is going out?
IB and I naught.
Okay, so what will be the equation?
I is equal to IB plus I naught.
IB plus I naught. Very good. Yes, very good. So if you rearrange, you can get IB. Everything is good. I don't have any issues. When the temperature is going to increase, when the temperature is going to increase, okay, when the temperature is going to increase, IC naught will increase. So for when IC naught is going to increase, for that your IB should be decreased. So this will automatically take place through the reverse bias diode, which is going to have a reverse saturation current I naught flowing through the device. So when the temperature is going to increase, I naught will also increase. When I naught is increasing, see the sign of I naught is negative, right? So when I naught is increasing, IB will reduce. So when IB is going to reduce, again IC will start reducing. So it is a feedback action. Okay, it is a feedback action. So what do we effectively ensure that whatever change in your temperature or collector current we are going to have the same value of IC flowing. And once again say, see, I'm going to have a diode at the base side which is reverse bias, and the reverse saturation current I naught is going to flow through my device. So whenever temperature is going to rise, IC naught will increase. Okay, so when IC naught is going to increase, definitely the Q point is going to move away. But since the transistor and diode are made up of same material, when IC naught will increase, this I naught will also increase. When IC naught is going to increase, this I naught is also going to increase. When I naught is going to increase, see the equation IB is equal to I minus I naught. So when I naught is increasing, IB will start reducing because I have a minus sign here. Okay, I have a minus sign here. So IB will reduce. When IB is reducing, IC will also reduce, which will ensure that the constant collector current is maintained throughout my transistor. So this is just a simple diode can ensure that the reverse saturation current is cancelled out. So how much ever increase in IC naught we have, that much amount your reduction in IB will happen, which will ensure that the collector current is also maintained to be a constant